Alright, this is Chris Robosprout. I'm just going to review some breakout board here that I made to make the pick and place modification a bit easier. So this board here connects to the smoothie board and uses up every single available GPIO header. There's two UARTs in there, and I only didn't use 3 pins that were related to the motor SPI so that they wouldn't, have any effect on the motor signal setup at the initial boot. But basically there's minus those 3, that leaves 60, and then minus the 4 UART, so that's 56 available pins. Now, not all of them were 5-volt tolerant, and so I had to add level shifters here, which you can kind of see them. They're FET-based bidirectional level shifters. Made them in a neat little package there. They have 2 per pack, and then so you use 2 of those and 2 R packs, and you got 4 level shifters. So it ends up being pretty tidy when you get it going. It's basically the same thing that SparkFun used to sell, the MOSFET-based bidirectional level shifter, and it takes it from 3.3 to 5 volt. So Smoothie's largely 5 volt tolerant, but not all of it. So this made all of the pins 5 volt tolerant essentially. So what happens here is this is booted up, and I have a ground here tied to this. So we're connected up to SmooPie, which is a host that Jim wrote specifically for SmoothieWare, and it gives you a lot of the information and connection or controls and such. So here's basically, it shows me being connected. Now if I go down here and just trigger one of these little pins to ground, you'll see that it sent a G code. So every time one of these pins triggers, Smoothie says send this G code string out the UART. Now then the UART connects, and I actually hack it in to this because the software for Bilsef's board here is set up to use the USB in on this Nano Every, but I actually hack in and cut these traces up there that are above that RxTX, and then I hack in down here on the level shifter, which, by the way, the idea for the level shifters I'm using, I kind of hijacked from this design here, since they have that BSS 138P package with a couple of resistors there. I made it with R packs instead, which is, I think, is tidier. But anyways, so basically the Smoothie receives a pulse from the pick and place through these parallel port connectors. One pin will go low, and then when that pin goes low, it's configured to say send this string out the 0 UART. So then it goes out the 0 UART and it goes into the Atmel chip here, which controls the feeders, and then these individually go out to the Siemens feeders and sets up all the commands for advance or whatever else I needed to do. So essentially what happens is, instead of this whole big cluster mess here, which I was using before, all that's done in this board. So now this board plugs directly into the pick and place machine via these parallel ports. I have to have a power supply that connects to this board, but it also for 30 volts for the Siemens feeders. But the Smoothie board also will run on 30 volts in. So you put 30 volts in there, you get your 5 volt, everything else you need to run this board also, and this thing. And so all this is real neat, and it'll just plug right in. Now, if I wanted to make this even less complex, I could just take this board essentially and modify the MCU and put in a different one and read the serial that's before the multiplexer inside the pick and place and read those serial signals, and then I would be able to eliminate all of this as well. But for now, this is a pretty neat little way to do it. And like I said, this was the level shifter board. I kind of designed it as just for this, but it gives an example of what you can do with the breakouts here. As a side effect, when I was working on this, I was testing and I was getting some pins that weren't registering when I triggered them, and I said, well, why aren't these pins working? I started logging them all down. Well, they ended up, all of them were pin 9s. Now, after a bit of searching around, I realized the problem was the ribbon cables. So when you're crimping these ribbon cables, you can shift that cable over there just ever so slightly in the housing right there, and if you don't get it right, the pin 10 will crimp to the pin 9 because they're so close. I don't know If it's a common thing, I don't know if it's just these, the ribbon cables I got and the connectors I got, but it certainly is happening. I'm going to shoot another video on how to test for that and how to avoid it, as well as I'm going to make a tester for the Gadgeteer header so that other people can, build it and use it or whatever they want. It'll probably be like an Arduino shield that'll do IDCs or something. I think it's going to be another little product I'm going to make. So something I need that I figure other people may need too. So, but yeah, for now, this just gives a good example of what, I'm working on to get these feeders going. So now I have the availability to connect up to, I'm going to have 45 feeders total right now, 8mm lane, and then after that I'm going to add in another just shy of 10 single lane that are the 12-16 feeders potentially, which will run the wider tape. I need them so I'm kind of gonna end up getting them, and it's really nice that this is all recycling feeders, which essentially would be, I mean, I don't know what they cost new, but they're fairly cheap on eBay, and they'd be garbage if they didn't have a machine to run them. And so now I'm reverse engineering and making this all work so that essentially my machine was a 2008, and they're saying this thing's past its prime, and these feeders were made in like somewhere between 2000 and 2005 from what the labels I've seen on most of them. And like I said, they would just be e-waste, ripped apart and thrown away, but there's so much complex machining and engineering that went into them that recycling and making them work on anything, whether it be open pick and place or a commercial machine like what I'm doing, it's always a good thing to not throw stuff out. So hope this was interesting to anybody who's working with a Smoothie or open pick and place and the Siemens feeders using Bill Seff's boards. This is a great board. There's a little info there on it. You can look it up. But Bill made it, and it has all the level shifters for 30 volt there on the bottom for every single one, send and receive, and then it controls them also through then with the Arduino firmware, or the firmware he has written for it. So it's very nice. It works with the 2-lane and the 3-lane feeders. I'm assuming it works with the 1 lanes, but I haven't tested that yet. So we'll see soon enough. All right, thanks.